Good morning and warm welcome to all the participants to the morning session of the day. Today we have with us Dr. Vijay Kumar Reddy, uh, and the topic chosen by our esteemed guest for deliberation today is fish protein isolates, an innovative way of utilizing seafood processing waste. Sir, you are audible as well as visible, and your presentation is also visible, and the recording has started. Please start, sir.
Yeah, very good morning. Sir, am I audible?
Yes, yes, you are audible.
Yep. Very good morning. Myself, Dr. Vijay Kumar Reddy, working as a scientist at College of Fisheries, Gurangadar Veterinary University, Ludhiana. Here we have been working in different aspects of fish processing technology from the past almost 9 years. So today I'm here to take you through an interesting topic, that is fish protein isolates, which is an innovative way of utilizing the seafood processing waste. Apart from though we have several well-established or standardized technologies for the utilization of the fish processing waste, but this fish protein isolates is a little different from that. The advantages of this we are going to discuss. So generally, if we are starting with the introduction, because there are wide variation in the audience. So it is protein is basically a Greek word that is proteus, that indicates the name of principal or prime that is given by the Mulder. And these proteins are the complex nitrogenous organic compounds. They are built up by the polypeptides, mainly the basic unit is the amino acid. So various amino acids, they form together to form small peptides. Then they will form together polypeptides. Then these polypeptides form a complete protein. So the total nitrogen percentage in a protein is around 16%. That is why whenever we go for any Jaldal calculation, we multiply it with the 6.25. That is because the protein contains around 16% of the nitrogen. So the proteins are the principal component of all the living cells. They are very much important in all aspects of cell structure and function. So starting from the basic functions to the advanced function, whatever the cell perform, that is mainly due to the presence of these proteins. And protein is one of the important biomolecule that is most abundant after the water, which constitutes sometimes over 50% of its dry weight. So we all know that protein is it is an important biomolecule. So the main basic, I can say the basic roles of protein in any living organism is for transporting the nutrients and producing vital body structures, maintaining the fluid balances, contributing to acid-base balance, forming the hormones, enzymes, and neurotransmitters, contributing to the immune functions, forming glucose by gluconeogenesis, and providing energy. There are multiple functions, a number of functions that are performed by the proteins in our day-to-day life. So if we see, like we all know, especially in the developing countries like India, we are mostly dependent on most of our staple foods. They include only, I can say, plant-based material, mainly maybe cereals or cereal-based products. And here we see like the recommended dietary requirements by the ICMR is, even in our day-to-day advertisement also we see we need a protein of 1 gram per every kg body weight. For example, if a person is of 60 kg, so daily he needs 60 grams of protein for his can say day-to-day function. And we also have like 0.8 to 2 gram per kg body weight protein is required during the recovery or growth stages. Sometimes it is 0.8 to 1.7 grams per every kg body weight in the athletes, because athletes they need a little higher protein for the I can say energy. They have the high energy requirement, so the requirement of protein also more. And even during the recovery and growth stages, we need more protein. That is why the recommendation is more. So on an average, generally for day-to-day life, we generally need 1 gram of protein per every kg body weight. So if we see the trends, we see you can say previous trends of protein consumption. So it has been continuously increasing. You can see the drastic change. It was around 39%. The protein consumption was around 39%. This is the percentage general population indicating they seek out foods that are high in protein. So out of the foods they consume, how much percentage they need the proteinaceous food. So the percentage was around 39% in the year 2006, which further grew to 53% in the 2014. And further it has been increased to more than 60% by the year 2020. So because the consumers who seek out foods that are high in protein have skyrocketed, because nowadays most of us, based on maybe because of our lifestyle, or maybe we are more aware of protein and its health benefits. So we are looking more towards the proteinaceous food. So this, you can say, this is the percentage population considering themselves deficient in the protein, because in the you can say previous times we were not having the accurate methodologies to measure our daily protein requirements, or maybe we were not aware much about the daily protein requirement. But because of the consciousness, or you can say increased health consciousness, as well as you can say change in the lifestyle and accessibility to the information. So now people are assessing themselves. Like most of the people, they try themselves to keep in the good. You can say they want to measure themselves whether they are protein sufficient or protein deficient. So you can see the population, those who were feeling protein deficient in the year 2010 was 11%, which grew to 21% in the year 2014, and it is further go to more than 25% by the year 2020 or 21. So this is because why we are showing these graphs are coming to us, why we were not having these graphs or calculation before 2005 or 2010 is mainly because we were not much aware, even though some other people they were aware, but they were not much health conscious. But the health consciousness has been increased. People, the demand for proteinaceous and nutrient-rich foods have been increasing. So people are assessing themselves whether they are really having, whether they are nutrient sufficient or nutrient deficient. If somebody is feeling themselves a nutrient deficient, they are going for the high amount of nutritious or proteinaceous food. So this is percentage generalized population. They are checking for the protein most often food or beverage product label. So now you can see most of the times whenever we go to any grocery store or whenever we go to any shopping mall, if we are buying something, we generally go to the nutritional labeling. So the people, now we are much aware of what is this nutrition labeling is, how exactly it is done, what are the major components, so which one we have to go for it. So generally whatever the food product we are choosing or selecting in the grocery store, that is mainly, it should be a fat deficient, but it should be rich in the protein as well as the other micronutrients. So the population, those who are looking for this labeling, has been increased from 19% in the year 2006 to around 27 or 30% by the year 2020. So out of every 100% that is they are going for the shopping or buying the groceries, at least 30 to 40 people, they are looking for the nutritional labeling of particular product. That means protein consciousness has been increasing day by day. So the new protein formats will also follow the macro food trend. This is the percentage GP indicating they look for foods or beverages with a short list of recognizable ingredients. For example, even if we are going and reading in the grocery stores, we have purchased some food product and we are reading the labeling. So how many of us exactly going through all the major and minor elements? So we generally look for the percentage protein, we generally look for the percentage fat, and we generally look for the overall percentage of the micronutrients. But we are not going to each and every ingredient on the list. So that is why it is indicating that when we go and look for any food product, we are mainly concentrating on the short list of recognizable ingredients. That is mainly protein and all the some of the vitamins. Otherwise, we are not much worried about anything. So this is the evolution in the protein consumption per capita, that is grams per capita per day. The protein consumption pattern has also been changing. And if you see the graph here, it is the graph is given for the developed countries, developing countries, as well as the entire world. So you can see in all the three cases, the protein consumption, that is gram protein per capita per day, has been increasing. Initially it was at 40 grams and then it has been increased to 60. Now it is moving more than 100 or 110. So this is the supplement. Like with the increased, you can say health awareness, people are flooding towards the gym or exercise center. So those who are going for more exercises, they need more supplements or more proteinaceous food. So that is why you can see this is the US protein supplement market. Here you can see different types of protein supplements. So the percentage protein supplement they are taking, it has been increasing day by day. So here the graph indicates the percentage black one indicates the protein powder. This is whether it is fish whey protein powder or it is some other protein powder. And these are the protein bars, and these are the ready to drink. These are the drinks that are ready to drink proteinaceous foods. These are some of the other components. You can see the graph, it has been drastically increasing. With the increasing, you can say awareness about the health, increasing awareness about the benefits of the protein. So the consumption of the protein in different forms also has been increasing. So why do we need protein? So there are different functions that a protein performs when it is supplemented to the food. So here you can see some of the functional properties of the proteins in the food. These are the different functional properties of protein, we have different functional properties like solubility, water absorption, viscosity, gelation, cohesion or adhesion, elasticity, emulsification, fat absorption, flavor binding, foaming, etc. So these are the different functional properties. So what is the mode of action? How exactly it is going to act? So solubility is, that is nothing but the how well the protein is solubilized in any solution, whether it is water or any other solutions, how well it is solubilized. So this particular property of the protein is mainly used in the beverages. Okay, when you are going to supplement protein into any beverages, or if you are going to make a protein rich drink, so the important property that you need to consider is its solubility. If the protein is good soluble, or if the protein is having good solubility, then only we can go for the beverages. So then we have another functional property of protein, that is water absorption and binding. So this particular water absorption is, this is the hydrogen binding of the water, that is mainly for the entrapment of the water within the structure. So this particular property is used mainly during the preparation of different meat products, sausages, breads and cakes, because they should be whatever the end product quality or texture that requires the water binding. So in that case, we need this water absorption property of the protein. So viscosity is the property that is nothing but the thickening or water binding again. So this particular viscosity is mainly required when you are preparing the gravies and soup. So if you are having any protein concentration, concentrated ingredient that we want to use it in the soups or gravies, so that is given by the viscosity. Then we have the gelation. Gelation is one of the most important functional properties of the meat protein, whether it is fish or other meat. So gelation is nothing but the formation of the protein matrix. So this particular gelation is one of the important criteria during the, you can say, product preparation related to the meats, curd and cheese. So then we have another functional property, that is cohesion or adhesion. So this, in that particular sense, the protein acts as a adhesive material. So this particular property of proteins is required during the preparation of products related to meat, sausages, baked goods and pasta. So then we have the elasticity. Elasticity is one of the functional properties given by the protein. So this is hydrophobic binding in the gluten and the disulfide linkages in the gels. So this particular property of proteins is required in the meat industry and bakery industry. Emulsification is one of the, you can say, important functional property again given by the protein. This is formation of the stabilized emulsions. That is when the two layers or two different ingredients are immiscible. So then we need the proteins to make them into an emulsion. So this is mainly used by the sausage industry, bolanga, soups or cakes industry. Then we have the fat absorption, one of the functional properties, that is binding of free fat in the products, that is used by the sausage, donuts and meat preparation. Flavor binding is one of the important properties of the protein that is used in the simulated meats and bakery products. And one more important property, that is foaming, that is to form a stable film to entrap the gases. This is mainly used in whipped toppings, chiffon desserts and angle cakes. So these are some of the industries or products where these particular different types of functional properties of proteins are used to get the required consistency. So now we are coming towards the fish proteins. So as we all know that protein content in the fish varies between 15 to 24% based on the type of species and based on the, I can say, condition of the fish that is being caught. So the protein content varies between 15 to 24%. So the most important thing or the good property of fish proteins is it contains all the essential amino acids and it is rich in lysine and methionine, which are, I can say, when we are talking about the fish protein, we call them as a complete protein, not like in plant protein. Plant proteins are incomplete proteins because they lack some of the essential amino acids. But these particular amino acids are present in, they are present in the fish proteins, that too in the appreciable quantity. So there are mainly three major fractions of fish proteins. So that include sarcoplasmic protein, myofibrillar protein and stroma protein. So out of these three portions, so myofibrillar proteins are the major one, which accounts around 70 to 80% of the total protein. And the sarcoplasmic protein, they account for around 8 to 10%, and whereas stroma protein that hardly accounts to 2 to 3% of the total protein content. So what are these sarcoplasmic protein contain? They contain all the water soluble pigments such as myoglobin, hemoglobin, globulin, albumins and different types of enzymes. So almost all of these sarcoplasmic proteins, they are water soluble. That means when you are subjecting the meat with the water washing, so most of these sarcoplasmic proteins will be washed away. So then we have the most important fraction, that is myofibrillar protein, which accounts around 70 to 80% of the total fish protein. So they are generally soluble in the neutral salt solution that is having the ionic strength of 0.3 to 0.6%. And this has the major subfractions like myosin, actin, tropomyosin, troponin, and actinin. So these myofibrillar proteins are the proteins which are responsible for different, you can say, important characteristics like gelation, or you can say chewability. So these are all the properties that are mainly given by the myofibrillar proteins. So then we have the stroma proteins, which are nothing but the connective tissue. This stroma protein content is very, very less in fish. That is 3% of the total protein content. So some of the, you can say, types of stroma protein include collagen and elastin. So that is why, because of the low protein content of stroma, because of the low content of the stroma protein in fish muscle, so the meat is very tender when compared to the other terrestrial animal meat. So now we have seen what exactly the fish protein contains, what are the subfractions. So now we see what are the different marketed forms of fish protein. So in the current stage, which are the different forms of fish protein that are available in the market. The first one, the most commonly termed or the most commonly seen fish protein type is the fish protein concentrate. So this fish protein concentrate is any stable fish preparation that is intended for the human consumption, in which the protein is more concentrated than is the original fish. So generally, what is the protein content of the general fish is? It is 15 to 24%. But here in the fish protein concentrate, it is the concentrated form which accounts with the protein content of 50 to 70%, with a fat percentage of around 1 to 20%. So this particular fat percentage, why the fat content is very high here is, here we are not doing anything, we are just concentrating the thing. So whatever the fish was having before, the same will be concentrated in final product. So if it is intended for the human consumption, then we call it as a fish protein concentrate. If it is not intended for the human consumption, a little lower grade is generally called as a fish meal, which is generally used for the animal feeding purposes. So here for the human, in the view of human edible purpose, we generally use this fish protein concentrate, which is having the protein content of 50 to 70%. So then we have the most important type of protein that is having the very high commercial value, that is surimi. It is a Japanese term. So surimi is a colorless, odorless, water-washed minced fish meat with additives prepared mainly from the white muscle of the low-cost fish. So here the surimi concept has come in 1900s, because when there were, you can say, huge number of bycatch was there, low-cost fish was there. So people were not knowing what exactly to do with that. So then they have started converting this particular low-cost white flesh fish into the surimi. So surimi is nothing but a water-washed minced meat. Water-washed minced fish meat that is not having any color or odor. So that is stabilized with the help of some of the additives. Then it is frozen as a frozen and kept in the frozen storage in the form of these blocks. So we call it as a surimi block. So then we have fish protein isolate. So this is what we are going to talk about. So fish protein isolate is one of the form. It is a kind of protein ingredient prepared from the different raw materials. So here you can see the difference you can easily make out. So this is again made from the original fish. This is just the concentration. Here this is made from the white muscle. This is made from the white muscle of the low-cost fish. But here it can be made from the different raw material. You can use any raw material. You can use a single species. You can use multiple species. You can use it. So without retaining the original shape of the muscle. So here what we are going to do in the fish protein isolate, we are just going to separate the protein from the different types of raw material, and we are going to stabilize it. So the fish protein isolate is having the protein content more than 85% in its dried form, and the fat content is less than 1%. So this is why it is very stable. The fat is almost negligible here, and the protein content is very, very high. So what are all the different methodologies we had to recover the proteins from fish or fish processing waste? The first one is the conventional surimi, conventional processing, which is also called as surimi processing. So these methods include repeated washings of the white flesh, followed by the screening, dewatering, and freezing. After the addition of cryoprotection, then it is frozen stored. So during the conventional surimi processing, we have to select the species or the fish which is having the white flesh. So for surimi preparation, dark flesh fish is not suitable. We have to select only white flesh. So after that selection of the white flesh fish, we have to take out the mince. That particular fish mince is repeatedly washed. So generally washing is done for not less than 3 times. So with the ratio of 1:10% of water. So this after multiple washing, this particular meat is screened through different types of sieves, then dewatering is done, then it is frozen with the help of some sort of, before freezing, some cryoprotectants are added, then it is subjected for freezing, then followed by the frozen storage. So the raw material for the preparation of the surimi include white flesh from fish or minced meat. So this particular surimi can be made only from the white flesh. So here we come to the pH shift processing. So pH shift processing includes single time homogenization with 6 to 9 volumes of water. So here you can use either 6 volume or 9 volume. That means every 1 kg of raw material you take, whether it is fish or fish processing waste, for every 1 kg of raw material you have to use 6 to 9 volumes of water, that too one time. So here in the surimi processing, it is repeated washing, generally not less than 3 times, but here it is hardly one time. So this particular homogenization, once you are mixing with the in water, then we go for the homogenization, followed by the pH adjustment. We are going to adjust the pH of that particular homogenate, then we subject it for a centrifugation. Then we will readjust the solubilized this one material to the its isoelectric point, and then followed by the centrifugation. So this raw material here include all types of fish, shellfish, processing waste, and byproduct. So here the main difference here is the one of the I can say advantages with the pH shift processing or fish protein isolate is when we are processing the surimi, the raw material should be only white flesh fish. But here you see the raw material is either it can be any types of fish, shellfish, processing waste, or any type of byproduct. So you bring any, if there is a mixture, a single species, you can bring any type of raw material that can be useful for the production of fish protein isolates. So here it is the process flow for the production of the conventional surimi process. Just for the comparison, here it is given. So in the general surimi processing, the fish is subjected for the mechanical deboning. We all know what is this mechanical deboning is. We are separating the meat from the bones. So after the mechanical deboning, mincing is done to make it into finer. Then after mincing, we wash multiple times with the water, at least 10 parts of water for every 1 part of fish. So then we go for the refining to take out the excess water, then dewatering is done. Then we are going to add the cryoprotectants. Generally there is phosphates or some sugars are added here. Then it is subjected for the freezing, followed by the frozen storage. Okay, this is the general, or you can say well established. We all know that it is a well established procedure for the production of the surimi, and it is at the industrial scale. So here this is the procedure for the preparation of the fish protein isolate, which is done. The process is generally called as pH shift process because the main principle here is nothing but the changing the pH. So in the pH shift process to produce the fish protein isolate, here we are going to take the raw material. Raw material can be anything, where it is fish waste or fish meat, or it is a mixture of fish meat or fish waste, or even it can be fish waste of different species. So you take the any raw material, then go for the homogenization with water. 1 part of fish required 6 to 9 parts of water. So generally, based on our experience, it is generally 6 parts of water is sufficient. That means every 1 kg of raw material you use, you have to add 6 volumes of water. Then we have to subject it for the homogenization, that is high speed homogenization. So during the homogenization, there will be proper homogenization, you can say, the particles will be well distributed and they will be made into finer. So then we go for the pH shifting. So the third step is the pH reduction or increase. We call it as a pH shifting. So here what happens generally, the proteins at its isoelectric point, they have the neutral charges, so it will not be solubilized in the water. So to make it solubilize in the water, either we have to reduce the pH or we may have to increase the pH. So generally in the pH shift process, what we do is we reduce the pH either to the acidic or we increase the pH to the alkaline to make the protein solubilized. So once the protein is solubilized, so then we go for the high speed centrifugation, that is generally 10,000 to 12,000 G with the help of the refrigerated centrifuge. So whatever the supernatant we get, that is nothing but the solubilized protein. So that particular supernatant is separated. Then we will adjust the supernatant pH to its isoelectric point. That is generally most of the fish protein, they have its isoelectric pH or isoelectric point. The isoelectric point is the point of minimum solubility. So we adjust the pH back to its isoelectric pH, that is 5.5. So once the pH is adjusted to 5.5, whatever the soluble protein is there, it gets precipitated. So this precipitated protein is again centrifuged at high speed, followed by the separation So the whatever insoluble sediment is there, the precipitate is that is nothing but the protein isolate. So here the same is given here. When we are going for the centrifugation for the first, here two steps of centrifugation are involved. This is the first centrifugation, and the next one is the second centrifugation. So after the centrifugation, here you see that particular there three layers will be formed. So first we are taking the fish, homogenizing it, adjusting the pH, then we are going for the centrifugation. So once the centrifugation is done, so after the centrifugation, the tube will be having three layers. The upper layer is that is the neutral lipids that are also not soluble, and the lower layer is the sediment that is also insoluble. So what we are going to take further is this particular dissolved protein or the soluble factor, which is given the red color. So here you see, because of this process only, whatever the lipid is there, the yellow this one, so it is also completely removed, and whatever the insoluble material is there, that is also completely removed. That is why whatever the soluble portion we are getting, it will be precipitated here. So once it is precipitated, that is why it is free of fat and it is free of all the unwanted material. So this is the advantage of this particular method. So what are the different advantages of pH shift processing are? So it is the pH shift processing or production of the protein isolate. It is applicable to all types of raw material or processing waste. You can choose any type of raw material without any compromise. The increase or similar yields compared to the conventional processing. So when you are employing the conventional processing, so it is not suitable to wide variety of raw material, whereas pH shift processing or protein isolate production is applicable to wide variety of raw material, and yields are comparable. So it is low cost technology. Here we are either using the acid or alkali, and hardly we are going for the centrifugation. Even the water usage is almost less, you can say 5 to 6 times it is lesser than the Solubility processing. So it is a low cost technology, and whatever the isolates we get at the end of this process having the good whiteness values which can be used for the food purposes, and whatever the protein isolate we get, because of having the very less fat content and very less unwanted contamination, is the protein isolate whatever we get here they are highly stable. They have the good storage stability. So this is the principle of getting the, you can say, fish protein isolate. So how we are going to produce the fish protein isolate? See, here you can see in the diagram in this image, at the neutral, at the isoelectric point, that is near to the pH 5.5 or 6, most of the fish proteins they are neutral. That means the positive charges and negative charges presented on the protein are almost equal. So that is why they do not interact with the, because the charges are neutral, they do not interact with the water. So what happens during the pH shift process? If you are going to add the acid, if you want to reduce the pH, what you do is you are going to add the acid. With the addition of the acid, this H plus ion concentration will be increased. The H plus ion concentration in the solution will be increased. So most of the ions, that is whatever the protein is having, the surface of the protein is completely occupied with the positive ions. It is completely occupied with the positive ions. So because of the positive ions on the protein-protein interaction will be defavored because of the repulsion. Because here also completely positive charges, the other protein molecule is also having the complete positive charges. So definitely there will be repulsion. So one side it is a repulsion, another side the protein, the negative ions on the water molecule will interact with the positive ions on the protein molecule. So simultaneously there will be the solubilization of the protein. Similarly, here if you see in the alkaline method, we are to the neutral protein which are having the neutral charges, we are going to add the alkali. So addition of the alkali is nothing but the addition of the OH minus ion. So with the addition of the OH minus ion, all the protein surface charges will become negative. Because of the negative charges, one side it will be protein-protein interaction will be defavored, and protein-water interaction will be favored. So with the increased protein-water interaction, this particular protein molecule becomes water soluble. That is why it gets separated from the other insoluble material. So this is the basic principle of the production of the protein isolate, or basic principle of the pH shift processing. So then we are going to look at the various characteristics of the fish protein isolate. So what are the properties of the protein isolate that are produced, fish protein isolate produced from the fish processing waste with the help of the pH shift processing. So generally if you see if you compare the proximate composition of the fresh mussel and protein isolate. So the fresh mussel, it has the moisture content of around 77%, and surimi is having the around 89% because of the multiple water washing. Similarly, the alkaline or acid protein isolate is having around 85 to 88% of the moisture. And you see the protein content is also comparable. The fresh mussel is having on dry weight basis 78%. surmi 91%, and this alkaline and acid protein isolate, they are having more than 80% of the protein, and the ash content is also higher here. And the lipid content, you just compare the lipid content, here it is given a little higher, but generally as per our experience and trials, so the lipid content in the protein isolate will be less than 1%. So here in the another study, if you see different types of byproducts and the simultaneous isolate they have given, the moisture content is less in the byproducts, which has increased in the isolate. And the fat content here you can see initially it was 41%, and which was further reduced to 10% and 13, 11%. So again, one more thing here we want to say is that again depends on the raw material quality. Whatever the final protein isolate you are getting, if you are going to use muscle, the final fat content will be very, very less. If you are going to use some sort of byproduct, a little higher fat content you can see in the protein isolate. So here you can see the protein content on the dry weight basis. Byproducts it was hardly 50 to 60%, but here you can see in the isolate that is increased to 80 to 90%, and the ash content is almost having the similar value. So here from the proximate composition table, we can see that the protein isolates, they are comparable to surmi in terms of its proximate composition. They have the good protein content, they have very less lipid content, so it can be used in the food process. So one of the most important property of this pH shift processing or characteristics of the protein isolates is lipid reduction. So during the pH shift process, the lipid is reduced to considerable level, and here you can see how much percentage of lipid is reduced. So various studies have demonstrated this. So Christians et al. 2006 he said acid, the lipid levels have been reduced
85 reduced by 85%, and here in the alkaline method is reduced by 88% again. So here you can see some of the methods they have indicated that the lipid percentage has been reduced by 90% sometimes, and even sometimes it is 95%. That means initially if the particular raw material was having 10 grams of lipid, so by the end the protein isolate will be having hardly 0.5 or 0.4% of the lipid. So this is the one of the important you can say advantage of this particular pH shift processing in the production of the protein isolate is the lipid content is highly reduced during the process. So then we have the solubility. So that is why we have to go for a different pH, and we should know when we are going to produce the fish protein isolate, we should know up to what pH we have to reduce. So if you are going for the acid or if you are going for the alkali, which are all the suitable pHs that we have to take it to. So you can see most of the studies they have reported the optimum pH. The optimum pH for the acid process is between 2 to 3. So the acidic pH, for example, if you have a raw material, protein isolate using the acidic method, then you have to reduce the pH of that particular homogenate to 2 to 3 pH. So in the alkaline side, it is generally 11. Most of the studies they indicated to produce stable fish protein isolate, we have to increase the pH of that particular homogenate to 11 to 11.5% if you want to produce the protein isolate using the alkaline method. So what is the minimum solubility or pH with minimum solubility? This is the blind mark. You can say on an average, the isoelectric point of most of the fish proteins is 5.5. Here even the studies indicated the same thing. You can see here. So the minimum solubility was recorded almost near to the pH 5.5. That means at 5.5 to 5.5 pH, the fish proteins have the least solubility. If you want to make solubilize that particular fish protein, either you have to reduce its pH or you may have to increase the pH of that particular solution. So recovery yields, in terms of recovery yields also we can compare it with the surmi process. More or less yields are a little lesser during the fish protein isolate production compared to the surmi. So different studies they have reported the yields for fish protein isolate. So here you can see the range ranging from around 30% to the maximum of 77%. That means every 100 gram protein that is present in the raw material, so the final protein to form the final protein isolate around 30 to 40 gram it will be reached to the final protein isolate. That means every 100 gram protein you process, the final end product you will be having the 40 to 50 grams of protein. So this is the recovery yield generally we have in the for the various species of fish. So this is the one of the most important thing, that is the amino acid composition. When we are talking about the proteins, the most important thing that we are going to look for is the what is the content of the essential amino acids and what is the content of the non-essential amino acids, and what is the content of the ratio of essential amino acids to total amino acids. So here you can see different types of it is clearly given in the table that what is the essential and non-essential amino acid content in the byproduct or raw material, and what is the essential and non-essential amino acids of the protein powders or protein isolates. That is also compared with the another protein rich products like soy, egg, and whey. And here some of the recommended levels also are given. So here you can see if we are talking about the essential amino acids, the byproduct that is having the valine content. If you are looking at the valine content in the raw material is around 44 and 44 milligram per gram, which has been increased to 62, 56, and 63 in the different fish protein isolate. So why this increase is there? That is nothing but the enrichment. That is because of the process. We are removing here the content is less because it is the particular raw material is also having the another component. But during the pH shift process, we are eliminating all the unwanted portion. So that is why they are concentrated. This particular amino acids are concentrated. And here you can see the protein isolates is having the valent content of 62%, 62 gram per milligram per gram, 56 mg per g, and 63 mg per gram. So, and the recommended levels of FeO or WHO is 39 milligram per gram protein. But these levels are very, very higher than the recommended level. So similarly, you can take threonine levels, isoleucine levels, leucine levels, whether it is lysine, whether it is glutamic acid, or maybe histidine or phenylalanine, whether it is essential amino acid or whether it is non-essential amino acid. The improvement in the essential amino acid content will you can see in the fish protein isolate. And here you can see the totality. At the end, you can see the totality of the essential amino acids. It is the byproduct is having around 473, 465, and 470 mg per gram essential amino acids they have. The similarly, you can see even the protein isolates is having the similar configuration related to the essential amino acid content. And here you can see the comparable one, which is very much fond of. You can see in terms of protein, soy we like very much, egg we like very much, and you will see total essential amino acid content in the soy protein is 371 and egg it is 395 and the weight is 414. And here you compare it with the fish protein isolate, which are having very, very high levels of the essential amino acid compared to this generally consumed protein foods. So similarly, here also the same thing is given, whether you are considering the essential amino acids or whether you are considering the non-essential amino acids. The level is very, very high in the, you can say, acid and alkaline process, or sometimes it is comparable to the surimi. That indicates that the pH shift processing or the fish protein isolate, whichever we produce with using whether it is fish or fish processing waste, they are having the very good amino acid profile. So color is one of the important attributes that is used when we want to produce the protein at industrial scale. So even the surimi, they are graded based. One of the important criteria to grade the surimi is color also. So color characteristics, if we see the whiteness of the you can say protein isolate, the whiteness of protein isolate here you can see it is ranging between 66 to 80 or 87 sometimes. That means whatever the protein isolates we get through the pH shift process, they are having the good whiteness values compared to the its raw material. So functionality, if you are seeing about the functionality, the main important property that we see is the gelation. So when we are considering the gelation, here you can see the breaking force is given here in the newtons. So here the second in the right side top table, the gelation, the gel type is given. That is, these are the 12, 12.5, these are the pH at which the protein is extracted, solubilized. So you can see at the pH 11.5 and the pH 12. So whatever the protein isolate we have, so they have the very good breaking force. They have the very good breaking force when compared to the gels made of the you can say raw material. So when you are using the normal fish muscle and when you are using the protein isolate, so even the protein isolate they are considered they are having the good gelling ability. That means I can say when we are talking about the gelation and when we are talking about the functional properties, alkaline processed isolates they are having the very good functional properties than the acid processed isolate. So to produce the protein isolate, we know that there are two methods. Either you have to go for the solubilization at acidic pH, or you may have to go for the solubilization at the alkaline pH. When we are talking about the acidic pH solubilization or acidic process, so during the acidic processing, the denatures of the protein will be higher. So because of which the functionality of the isolate will be reduced. But alkaline processing is far better compared to the acidic process in terms of its functional properties. So then we have the digestion. Some of the reports have also indicated the better digestion properties of the protein isolate compared to the normal, you can say, fish muscle. So here it is given the main purpose of giving this particular this thing is, So here you can see the digestion pattern of the fresh muscle and protein isolate by the pepsin. So the author, the researcher, he has used two systems. One is in vitro digestion pattern he has observed. One is by using the pepsin, another one by using the alpha chymotrypsin. So the differences with the help of the pepsin, it is very much difficult to differentiate. So that's why he again used the alpha chymotrypsin. So after his studies, he saw that at a particular time, after a particular time, the disappearance of the myosin heavy chain in the protein isolates is very, very higher. The rate of disappearance is very, very higher than compared to the fresh muscle, which indicates that this particular fish protein isolates is having a very good digestibility compared to the normal fresh muscle. So this indicates that the particular, whenever we are subjecting the fish proteins to whether it is for the acidic process or alkaline process, it will cause some sort of I can say fragmentation of the protein. Further, it will fragment this myosin heavy chains into the smaller component. They will further degrade into further smaller component, which will be digested easily. So the conclusion of this particular slide is that they want to indicate that the fish protein isolate, they were also having the very good digestion when compared to the fresh muscle. So when we are talking about the product application of the fish protein isolate, not only it's just I can say isolation and characterization, some of the attempts have been made for its product utilization also, because the success of the technology is directly indicated in terms of its application. So Leon et al. In the 1990 itself, he produced the fish protein isolate and hydrolyzed. So they extracted the proteins from the mullet and they made the powders using it. The powders with 90% protein would give the 20 to 35% of the concentration of the final product. That means whatever the end product they got, that was having the protein content of 30%, and around 70% of the testing panel they have accepted this particular product. So in the year 2008, Shaviglo, so he made the fish mince balls with the help of the fish protein isolates obtained to the pH shift process. So they suggested that haddock proteins can be used for the development of the mince-based products. So even after the centralized studies, they could find out that fish protein isolates can be applied to prepare the fish product or to supplement various fish products. So similar studies were conducted by the Ibrahim to prepare the fish balls using the fish protein isolate. So they indicated that it has a good biological value and protein efficiency ratio. So even the amino acid content was very much here in the end product. So similarly, Surasani et al. In 19 they have supplemented semolina pasta. General pasta was supplemented with the fungus protein isolate at various levels. So at the end of the studies, they could conclude that a considerably acceptable pasta can be made by supplementing the fish protein isolate that is not having any odd powder or off flavor, and up to 5% level of fish protein isolate can be used to supplement the pasta. So similarly, in the year 2019, there was a study indicating the supplementation of fish protein isolate to fish sausages. So here also they concluded that among the levels tested, fungus protein isolate at 10 gram per 100 gram mince can be used to produce the sausages with better functionality and good sensorial acceptability. So all these studies indicate that not only just recovery and characterization, this particular fish protein isolates can be used in the food product, various food products, wherever there is a requirement of protein. So it can be used as a protein substitute in the different food product with the good consumer acceptability. So when we are talking about the storage stability, as we have already seen in the previous slides, we have seen that the protein, whatever the protein isolate we get, they are more stable compared to the other fish muscle protein because they have the very less fat content and they are already, I can say, they are separated from the all the sarcoplasmic protein, which are mainly responsible for its degradation. So, but still you can see some of the studies indicated that the protein solubility of surimi prepared using pH shift process was more compared to the conventional surimi. So when they have prepared the surimi with the help of the fish protein isolate, it was having the more solubility, which is the important I can say parameter, and they have the very less lipid levels. So the whatever the pH shift based surimi was, it was having the more shelf life compared to the conventional surimi. That means the storage stability was very, very good when they have prepared the surimi with using the fish protein isolate. So it was also found that the gel structure was maximum when proteins were added with the cryoprotectants and stored at pH 5.5 and 7 without feast cycle. That means even though the protein storage stability of fish protein isolate was very, very good, but still they needed some sort of cryoprotectants to keep it at the maximum level. So here the similar study was conducted by the Shaviglo in the year 2008. So he also suggested that pH shift processing also need to be added with the cryoprotectants to protect them from the denaturation during frozen storage. So all these studies indicated that Even though this protein isolate, fish protein isolate, they have the good storage stability. Still, for better stability of this protein and better shelf life, they must be added with the cryoprotectant before they are subjected for the freezing. So now we are coming towards the end. So what would be the future prospect of that this particular fish protein isolate or PSU processing is? As low protein yields are the major drawback of the technology, combination of other methods should be used with PSU process which can reduce the loss of protein during the processing. So here you can see in the previous slides, we have seen that some of the slides indicating the protein recovery, sometimes it was 30%, sometimes it was 40%, and the maximum of 60%. That means the yields are less compared to the other method. So the yields can be increased by adopting some other technologies. More work is needed in this area to find an appropriate technology which can improve the protein yields without affecting the functionality. So the main thing is when you are subjecting it to the some other treatment to improve the yield, simultaneously there will be a considerable effect on its functionality. So we should go for a technology, we should go for the particular method which will be having the least effect on the protein functionality during the processing. So one more important concern or why this particular fish protein isolate they couldn't be successful in its application into the food industry is mainly due to the usage of the chemical. So as you have seen, we are mainly using the acid or alkali for the solubilization or precipitation of the protein. So there is a chance of its residues in the end product. So use of chemicals during solubilization precipitation and the possibility of these residues in the recovered proteins is a major concern. So which needs an alternate biological method for the protein recovery. So now the studies have been concentrated mainly to find a better method or to find a more biological method for the recovery of the proteins. So instead of using the chemicals. So these are the future prospects where we are going to work now. So this is all for today. Thank you so much for your patience. Now this is open for the discussion. Thank you. Mr. Hamida.
Thank you, sir. Thanks a lot. Now, if there are any questions, I'll invite participants to ask them. I'll turn on their microphone. They can ask their questions. They can ask in chat or on their microphones. Are there any questions or interactions people want to do? They can do it right now. If not, then we can consider the session to be over. I don't think there are any questions. Mostly people didn't ask any or have not mentioned any question in chat. So on behalf of the participants and on behalf of the organizing committee, I would like to extend our heartfelt gratitude to you, sir, for being with us. And it will look forward to future interactions with you. Thank you, everyone. Thanks, sir. Thanks for being with us.
Thank you so much for the opportunity and thanks for the patience. Have a good time. Thank you.
Thank you.